Okay, still lesson 5.4, part 3. It just keeps going, doesn't it? All right. So, we're just going to jump into an example right here, right away. 5y squared plus 20 equals 0. You could use quadratic. I mean, it is quadratic to solve. We could use, well, we'll get to quadratic formula a little bit. We're going to kind of continue on with the method we've been using. We're using imaginary numbers. So what I'm going to do is actually try to get y by itself. Okay, I'm going to isolate y's. I'm going to subtract 20 from both sides. Now I'm going to divide by 5. And now I have y squared equals negative 4. Okay? Well, what number times itself gives you negative 4? 2 times 2 is 4. Negative 2 times negative 2 is 4. It has to be the same number times itself. So we go back to our, how do you undo a square? You undo a square by finding the square root. Okay? And this little 2 is a clue for you that you have two answers, the positive and the negative. So now we have y equals plus or minus, and now we have an imaginary number coming out. We have 2i. That's basically the brunt of it right there. Okay, let's go on to this next one. We're actually not going to do this problem right here. Let's go to this one right here, kind of the same idea. 2x squared, I'm going to subtract 50 from both sides because I'm trying to isolate my x. So I have negative 50. All right, divide both sides by 2. Now I have x squared equals negative 25. You look at that, probably right off the top of your mind, you want to say 5 or negative 5, but it really doesn't work that way. You have to undo the square by finding the square root of negative 25. And we have to remember this little 2 is a clue for you that you're going to have two answers, a positive answer and a negative answer. So x actually equals positive or negative, and this comes out to be 5i. Okay, next idea here. A complex number is any number that can be written in the form a plus bi. A and b are real numbers and I is the imaginary part. So kind of you have real numbers and you have imaginary numbers. A is the real part, B is called the imaginary. I just repeated what I just said there. All right, so here they have 7 plus 4i and 2 minus 6i equals 2 plus negative 6i. All right, well, we're moving on here. So we've got this. Here I got an example written out in the book form. 2x plus y, actually this one I don't want you to copy down. Example 3 you can kind of bypass copying down if you just at least follow along. 2x is this part, yi matches this part. That's why 2x is equal to the negative 14, and they solve that and they get x equals negative 7. I feel like some little piece is missing here. We have yi is equal to negative 3i. Well, I matches the I, so y has to match the negative 3, hence the reason why this is written down here. So x is equal to negative 7, y is equal to negative 3. All right, let's try this out. You do have to copy example 4. Okay, 3x is going to be equal to this part, the 15. Negative yi is equal to the 2i. Well, over here, x is 5. Over here, I have I equal to I, but now I have to match. I'm going to rewrite this just so we can see clearly. Negative y is equal to 2. Well, if negative y is 2, then y is equal to negative 2. Okay, find the values of x and y that make the equation true. Well, there you got it. Example 5. All right, now we're not finding the values of x and y. Here we're just simplifying. We're going to work with imaginary numbers and complex numbers just like we do any other variable. So you can almost think of I as a variable instead of an imaginary number. In this particular one, parentheses don't matter. I can't say that for every problem, but in this problem, parentheses are not going to matter. I have plus 2. I have minus 4i. Come on in and just record it, so you know. All right, 5i and negative 4i is I. 3 plus 2 is 5. And I am not going to be particular if you write I plus 5 or 5 plus I. Did I say the same thing twice? Example 6 and 6b, I guess we're going to call this. Once again, combine the parts that do not have imaginary numbers, so I have 5. Combine 6i and 4i, 10i. So it looks kind of scary to begin with, but then you're like, oh, that's not so bad. I can do that. Try it again over here. We got 3. Uh-oh, I got a negative out here. Let me rewrite that. 3 plus 2i. So now the parentheses do matter. I have a negative in front of a set of parentheses. That's negative 2 plus 5i. This means I have to take negative 1 times everything in the parentheses. So I have 3 plus 2i. Negative times negative is positive 2. Negative times 5i is negative 5i. So 3 plus 2 is 5. 2i minus 5i is negative 3i. And that is your answer. Same kind of problem right here. We have that subtraction right there in front of a parentheses. We miss this a lot. For as much as we know it, we still seem to be kind of missing it here and there. So I'm going to have negative 1 times 3, which is negative 3. Negative 1 times negative 7i is positive 7i. Another way of thinking that, I usually just think switch the signs. If I'm doing it by myself, I just switch the sign, and call it good. Then combine like terms. 4 minus 3 is 1. Negative 6i plus 7i is just I. 1 plus I. Example 8. In AC current, the voltage E, current I, and impedance Z are related by the formula E equals I times Z. This is, don't let this freak you out. This is I times Z. Don't worry about the underline. Find the voltage in a circuit with current 1 plus 4j amps and the impedance 3 minus 6j ohms. So it's kind of like a science question. So your E, find the voltage. So we want to find E, which is our voltage, is equal to I, which is the current, and they tell us the current is 1 plus 4j. And then they have time, so I'm going to put this as a group, because if we have two things like this, and we're going to multiply, and then we need to say that's a group. And the impedance, which is Z, right? And the impedance Z, so that's 3 minus 6j. Okay, now we have like a binomial times a binomial is what we're looking at. So I'm going to multiply we're going to FOIL basically. So 1 times 3 is 3, 1 times negative 6j is negative 6j, 4 times 3j is 12j, and I have a sneaking suspicion, negative 24j squared. I bet that's supposed to be an I or something in there, as in like imaginary number, because we're just going to keep working it through. All right, E equals 3 plus 6j minus 24j squared, and I think this problem has some problems in it, but we're going to leave it right there and move on. Should have double checked that. Example 9, kind of the same as we've just been doing. And notice how there are I's in here, which is another reason why I think in electricity they often work with imaginary numbers too. So we're going to FOIL. First, outer, inner, last. Negative 3 times 2 is negative 6. Negative 3 times 2i is positive 6i. Negative I times 2 is negative 2i. Negative I times negative 2i is positive 2i squared. Combine like terms, so I have negative 6 plus 4i plus 2i squared. Oh yeah, I squared is negative 1. Okay, you probably don't have to show this many steps, but I have 2 times negative 1. We can never leave an I squared as our answer. So now I have negative 6 plus 4i minus 2. Oh, now these are like terms. So I have negative 8 plus 4i. Done. Let's try it again over here. First terms, 9. Outside terms, 12i. Inside terms, negative 12i. And last terms is negative 16i squared. These cancel out. So now I have 9 minus 16. Except for the I squared, I don't write I squared. I write negative 1. So I have 9 plus 16, which is 25. Lovely. Okay, complex conjugates. Two complex numbers of the form a plus bi and a minus bi. So if you have 2 plus 3i, its conjugate is 2 minus 3i. If you see 3 minus 4i, the conjugate is 3 plus 4i. If you have negative 3 plus 2i, you write negative 3 minus 2i. Those are your conjugates. The product of two complex conjugates is always a real number, and that's the point, is we're going to have this in the denominator, and we are not going to be able to figure out, leave anything with complex numbers in the denominator. Yeah? Yes. Okay, so in example 10, notice how we have 3 plus 2i in the denominator. And we cannot have your imaginary numbers cannot stay in the denominator. Notice, and even complex for that matter. We cannot have that I in the denominator. So what we're going to do is we're going to multiply by the conjugate. So 3 plus 2i. But here's the kicker. If we multiply by the complex conjugate, that'll be 3 minus 2i. This fraction here has to basically have the value of 1. So I'm going to take the top also times 3 minus 2i. Okay, now when I take the top times the top and the bottom times the bottom, 5i times 3 is 15i. 5i, let me think of it like this, 5i times 3, 5i times negative 2i is negative 10i squared. Now in the denominator, I got this complex stuff because it looks complex. 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is 6i. And 2i times negative 2i is negative 4i squared. Now it looks even more complex, but is it? All right, look at this top part. 15i, and then I have negative 10, and this is negative 1. So I have negative 10 times negative 1 is positive 10. Over. Now check this out. Negative 6i and 6i go away. Or cancel out, I should say. Then I have 9 minus 4. I squared is negative 1. So really, when I simplify this, I have 15i plus 10, and then divided by 9 plus 4. Ooh, I should have maybe done that all in one step. 15i plus 10 over 13. Now you did all that work basically to get rid of this, which has complex, it has imaginary numbers in there, and now suddenly we have, a rational denominator, which is what the math world loves. This is a mathematical ticket to nowhere, and this gets you full credit. That's why we do all that work. Example 11, 2 plus I over 1 minus I. Once again, we're going to work with a complex conjugate. So you're going to take both the top and the bottom times the conjugate, which is 1 plus I. What you do to the denominator, you must also do to the numerator there. This has a value of 1, so I'm not changing the value of this, I'm just changing the way it's written. Okay, so I've basically got to FOIL my top, so I have 2 plus 2I plus I plus I squared. FOIL the denominators as well. 1 times 1 is 1. The outside is 1 times I. The inside is negative I. The last terms are negative I squared. Ooh, check it all out. There's lots of stuff to simplify here. I got 2 plus 2I plus I. So I got 2 plus 3I. Oh, I squared is negative 1. Oh, cool how this always happens with your complex conjugate. You get rid of the inside terms, the FOIL. 1, and then I have minus, and look how I write this minus matches this one, and then I have I squared. Well, I squared is negative 1. Okay, simplify the numerator. So the numerator becomes 2 minus 1 is 1 plus 3I, and 1 plus 1 is 2. And now you're done. And that's it. Here ends another beautiful lesson of Chapter 5, Algebra 2.